Hello, and welcome to Backer Breaks It Down. In this episode, we are going to take a look at some other trig relationships. So it's going to take us a little bit beyond sine, cosine, and tangent. Secant is one of those. All right, so these three trig ratios are known as the reciprocal trig ratios. Okay. Cotangent, abbreviated COT, right? COT of angle A. The cotangent of an acute angle in a right triangle is the ratio of the length of the side adjacent to the angle and the side opposite that angle. So cotangent is the adjacent over the opposite. Cosecant of an acute angle, so cosecant is abbreviated CSC, is the ratio of the length of the hypotenuse to the length of the side opposite that angle. So cosecant is the hypotenuse over the side opposite. And then secant, abbreviated SEC, of an acute angle in a right triangle is the ratio of the length of the hypotenuse to the length of the side that is adjacent. So secant is hypotenuse over adjacent. So these three trig ratios are still using those three sides of a right triangle. They're just, they're similar to the big three. So let's actually find some ratios for triangle ABC here. Notice that we're going to focus on angle A. So if angle A is our angle of reference, that means the 5 side is the opposite, the 12 side is the adjacent, and the 13, well, that's your hypotenuse. So cotangent, remember cotangent is the adjacent over the opposite. So the adjacent is 12 and the opposite is 5. Cosecant, that's the CSC. Cosecant is the ratio of the hypotenuse to the opposite side. So the hypotenuse is 13 and the opposite side is 5. And then secant, that's SEC, secant, is the ratio of the hypotenuse over the adjacent side. The hypotenuse, is 13 and the adjacent side is 12. So we're still finding these ratios just like we found sine, cosine, and tangent. They don't have like a nifty little remembering device like SOHCAHTOA, unfortunately. Okay, but why do they call these like reciprocal functions? Okay, well, let's think about the big three, sine, cosine, and tangent, starting with tangent, right? So like I know tangent, like when I'm thinking about tangent, this is like the image that appears. So tangent is the opposite over the adjacent. So opposite angle A is the side measuring 5 and 12 is the adjacent. Okay, what do you notice? They're reciprocals. So cotangent and tangent are reciprocals of one another, and you flip to find the recip, right? I know, I'm wondering about cosecant and secant myself, okay? So let's check it out. Because like clearly I have put sine right underneath cosecant, so that must mean something, right? So I know sine is the opposite over the hypotenuse. So the opposite is 5 and the hypotenuse is 3. And yeah, like I totally did that on purpose because cosecant and sine are reciprocals. You flip to find the recip. And so, of course, that must mean secant and cosine are reciprocals. Cosine is the adjacent over the hypotenuse. So that's going to be like 12 over 13. So they are. So cotangent, cosecant, and secant are called the reciprocal functions because they're reciprocals of our big three. Okay, and so like this is my like goofy way of showing, hey, you just like flip to find the recip, and that's how you find cotangent. So if I know sine, flip, find the recip, that's cosecant. If I know cosine, I can flip it, find the recip, and that's secant. Okay, so we don't really need a silly little mnemonic device to remember like the ratios for cotangent, cosecant, and secant. We just need to know like which of the big three they're like buddies with, okay? And so in this problem here, I want us to find all 6 trig ratios. And honestly, my advice, I give okay advice, I think, but in math, I gave good advice, okay? Find the big three. And then once you find the big three, flip to find the recip, okay? And so looking at this diagram here, this is a classic like trig diagram because it's taking a triangle and it's putting it on a circle. Like this is classic trig. And so the fact that this point right here is at 6, 8, the x value is 6. So that tells me like the horizontal length of that triangle is 6. And then the y value of 8 tells me the vertical side is 8. Now, we technically know the hypotenuse already. Do you know why? No? Here, I'll show you. So the hypotenuse goes from the center of our circle to a point on our circle, and we call that a radius. And we can see that in this circle, the radius is 10. Otherwise, we could always do the math. We can always do the Pythagorean theorem and come up with it that way, but it's 10, okay? So I'm gonna like find my big three first because those I feel are like the easiest to do because they have that little mnemonic that helps us. And so for sine, I have SOH. So sine is the opposite. It's the opposite of theta. If you're wondering like, what is that? This is called theta. It's a Greek letter. It's very commonly used for angles. Okay. So sine of theta is going to be opposite over hypotenuse. So the opposite is 8 and the hypotenuse is 10. And of course I should reduce this. So sine is 4 over 5. And then when it comes to cosecant, I can just flip to find the recip. So if I flip 4 over 5, I get 5 over 4, and that is cosecant. Now I'm ready to find cosine. I know cosine to be the adjacent over the hypotenuse. So adjacent to angle theta is 6, and the hypotenuse is 10. So I reduce this, and I get 3 over 5. And then secant is the reciprocal of cosine, so I'm going to take 3 over 5. I'm going to flip it, flip to find the recip. Secant is 5/3. And that leaves us with tangent. Tangent, TOA, is the opposite over the adjacent. Opposite theta is 8. Adjacent to theta is 6. So then I reduce this, and I get 4/3. And then for cotangent, I flip to find the recip, and I get 3 over 4 for cotangent. And so finding the reciprocal functions are pretty easy. So long as you know which of the big three they go with, then it's just a matter of flip to find the recip. I'm going to save this problem for our in-class time because it's that good. I know you're looking forward to it, okay? But for now, that's how Backer breaks it down.